Hello students, welcome to the video class for the subject Power Electronics and PLC, and this video class is for 5th semester Electrical and Electronics Diploma Engineering students. So today's topic is your operation of chopper in all 4 quadrant. It is also known as 4 quadrant chopper or type E chopper. So in this video session we will discuss the working principle of 4 quadrant chopper with its circuit diagram and the output in the quadratic manner. In the quadrant, in the 4 quadrant, we will see how the choppers operate in all the four quadrant. Okay, so let's begin with the working principle of this 4 quadrant chopper. So this is your circuit diagram. Okay, so power circuit diagram for 4 quadrant chopper. So it consists of 4 semiconductor switches, CH1 to CH4. See, chopper 1, then chopper 2, chopper 3 and chopper 4. These are the 4 choppers are connected in bridge form, and then 4 diodes are there, that is D1, D2, D3, D4, connected in anti-parallel. Chopper and diodes are connected in anti-parallel form. So numbering of choppers are CH1, CH2, CH3, CH4 and corresponding to their respective quadrant operation, and corresponding to their respective quadrant operation, like for first quadrant operation, only chopper 1 is operated. For second quadrant operation, only chopper 2 is operated, like this. And working of this chopper in all the 4 quadrant is explained as under. So see, what happens here. So first we will start with the first quadrant operation. So for first quadrant operation, chopper 4 is kept on. It is the initial condition. Chopper 4 is kept on, chopper 3 is kept off. Okay, chopper 4, this is the chopper 4, this is on, and chopper 3 off. It is written here, chopper 4 on and chopper 3 off. Okay, so with chopper 1 and chopper 3 off, and here chopper 1 is operated. Okay, in first quadrant chopper 1 is operated. So with chopper 1 and chopper 4 on, load voltage V0 is equal to Vs. That Vs is the source voltage. See, here the source is this much, and here the given I0 and V0 direction assumed to be the positive direction. Okay, so see what happens. So when chopper 1 and chopper 4 on, and load voltage is now load voltage V0 is equal to Vs, and load current I0 begins to flow. This is the path I have shown here. See, through chopper 1, then through load, then through chopper 4, and then back to source. This is the path of current flow. So then when chopper 1 is off, positive current free wheels through chopper 4 and D2. See, when chopper 1 is off and initial condition is chopper 4 is on, so when chopper 1 is off, this current will free wheels through chopper 4 and diode D2, because due to this inductor, now this diode is in forward biased, because initially in inductor it is positive and it is negative, but when current flow through the load, after some time across inductor, the EMF polarities, this is plus and this is minus. Due to this, the D2 is forward biased, and it is the current free wheels like this when chopper 1 is off. Okay, so see, and in this manner both V0 and I0 can be controlled in the first quadrant. See, note one point here, that type E chopper operates as a step down chopper in first quadrant, and this is the in the graphical form I have shown here. This is the first quadrant operation shown here. This is the first quadrant where b0 and i0 both are in positive direction, and uh, that's why it is operate in first quadrant. So this is represented here, b0 positive, i0 positive in first quadrant. Okay, so this is all these things are explained here in the first quadrant. For first quadrant operation, see whatever I told you, these are all explained or mentioned here. Okay, and then next come to the second quadrant. This is your second quadrant diagram, circuit diagram. In this circuit diagram, see, this is the supply bs. 4 choppers are here: chopper 1, chopper 2, chopper 3, chopper 4. And in the load, emf is present here. One emf is used here. This is E, its polarity, this is positive and this is negative. And one inductor is connected in the load with the load, and 4 diodes D1, D2, D3, D4 are connected in anti-parallel form. So in second quadrant, all chopper 2 is operated. That means chopper 2 is kept on, and chopper 1, chopper 3, chopper 4 kept off. So here only chopper 2 is on. So see what happens. So when chopper 2 on, reverse or negative current flows through. That means it is like this. See, all the choppers are off, only chopper 2 is on. So here E act as a source, so current flow like this path through chopper 2, and then this is the mean current flowing direction. This is the path. See what happens here. Current flows through L, CH2, D4 and then E. Okay, so here inductance L stores energy during the time chopper 2 is on. So when chopper 2 is turned off, current is fed back to source through diode D1 and D4. And note that here E plus L di by dt is more than the source voltage Vs. See, when current flowing in this direction, this is the opposite direction as compared to the assumed direction. This is the assumed direction, it is here, and our current direction is opposite with this assumed direction. So here current is negative, but voltage is positive here. Okay, because current is from flowing begin to from this point, so it is positive and it is negative. So here this point is positive and this point is negative. Okay, because current starts from this point and enter here. So this is positive, this is negative. So here voltage polarity is positive and current polarity is negative. So that's why it is in second quadrant. This is the second quadrant. Here in this part, see what here, voltage axis is positive and current axis is negative. So this is the second quadrant operation. And see what happens here. When chopper 2 is off, at that time current reverse back to the source, or when the chopper is off, current is fed back from load to source through the path. This is the path through the diode D1 and D4. Okay, so feedback to the source like this. This is the path. See, I have drawn here. This is the path for, this is the total path like this. This is the path. When chopper 2 is off, current is feedback from load to source through D1 and D4. Okay, so this is all about second quadrant operation. And note that in second quadrant, the configuration operate as a step-up chopper. Why it is called as step-up chopper? Because here power is fed from load to source. That's why, that means here the load side voltage, that is E plus L di by dt, which is greater than the source. That's why it is also operate as a step-up chopper. Now this is your third quadrant operation, and this circuit diagram is for third quadrant operation. And in this circuit diagram everything is similar with the first quadrant and second quadrant circuit diagram, except one thing, that in the previous part this EMF load with the load, the EMF connected with the load is connected like this it is positive and it is negative. But in third quadrant the load EMF must be reversed, so it is like this. The load EMF must be reversed, which is reversed here. See, okay, this side plus and this side minus. Okay, so what happens in third quadrant operation? Okay, let's see. So for third quadrant operation, chopper 1, the initial condition is chopper 1 is off, chopper 2 is on, and chopper 3 is operated. So polarity of the load EMF is reversed. See, when chopper 3 is on, load get connected to source Vs, so that V0 and I0 are negative, leading to third quadrant operation. See, when chopper 3 operated and chopper 2 is on, it is the initial condition, then current is flowing like this. This is the path through chopper 3, and then through load, then through chopper 2, and then back to source. So in this way load is connected with the source. So see, in the load both current, output current and voltage are in opposite direction, okay, or reverse direction or in negative. That's why it is in third quadrant. So see, now the output is output both current and voltage negative, that's why the output is in this quadrant. Here output is playing, here voltage is also negative, current is also negative. Okay, so see, when chopper 3 is turned off, now if chopper 3 is turned off, negative current free wheels through chopper 2 and diode D4. So how the negative current free wheels? See, it is free wheels like this, through, this is the path through chopper 2, and this is the path through D4, and this is the freewheeling direction of freewheeling current when the chopper 3 is off. So negative current freewheels through chopper 2 and D4. So see, current direction is also here reverse, negative, as compared to the assumed positive direction of current. So in this manner, voltage, output voltage and output current V0 and I0 can be controlled in the third quadrant. Here chopper operate as a step down chopper. Okay, so this is everything is explained here. In this part you go through these things. Okay, and the last one is the fourth quadrant operation. So this is the circuit diagram for chopper, so for fourth quadrant operation of chopper. So here the initial condition is your chopper 4 is operated and all other devices are kept off, that means CH1, CH3, CH2 is off and only chopper 4 is on. So when chopper 4 is operated, positive current flows through chopper 4 diode D2 and L and E. So when this is operated and through this, here EMF is also reversed, this is positive and this is negative. So once chopper 4 on operated, so current will flow like this path. So see, here current direction is same and is same with the assumed I0 direction, but voltage is reversed. So that's why here I0 is positive and V0 is negative. So here the output is like this. So though here V0 is negative and I0 is positive, so output lies in fourth quadrant. This is your fourth quadrant operation. Okay, so See, so this is the current direction when chopper 4 is operated or it is in on condition. But when chopper 4 is turned off, current is feedback to source through diode D2 and D3. See, inductance L stores energy during the time chopper 4 is on. So during the chopper 4 is on, when this current is flowing through this path, inductance will store energy. So once chopper 4 is off, current is feedback to source. Current is feedback to source through D2 and D3. So the feedback current direction or current path is like this. This is the path through which current is feedback from load to source. Okay, so here voltage is negative but current is positive, leading to the chopper operation in fourth quadrant. Okay, so power is feedback from load to source. Here in fourth quadrant operation, power is feedback from load to source. That's why here chopper operates as a step up chopper. Okay, so everything about the fourth quadrant operation is mentioned here, and this is uh, all about your operation of chopper in all four quadrants. Okay, so go through these notes and maintain your note in your notebook. Okay, starting from this, you maintain the note by following this. Okay, thank you.